Hey guys! So in the last lesson, we learned about the different built-in commands and functions that can help us to describe our data frame and series objects. We also learned about the different data types that we can use to store and represent our data. All these functions and commands can help us to identify if there are any potential problems or fixes that we need to apply on our data frames before the data can be ready for further analysis. In this lesson, we will learn about the most common techniques that help us to do data cleaning and data processing on our data set before they can be ready for further analysis. So let us quickly start with lesson number 6, data cleaning in Pandas. So data cleaning is actually one of the most common tasks for any data professional. Usually, real-life datasets come with a large number of issues and problems, such as missing values, having the wrong data type, or maybe even bad formatting. That's why data professionals usually need to spend some time correcting these issues before the dataset is ready for further analysis. Luckily, the Pandas library has a lot of built-in functions that can help us to fix these issues. So we will go through some of the most common issues that we need to do for data cleaning. To demonstrate that, we will use some dummy datasets about countries' information. We create that using a method that we already learned before by transferring Python dictionaries into a dataset. So by looking at this dataset, we notice a few issues that we need to take care before we start our analysis. First, we notice that the rows for the country of New Zealand was repeated 2 times in our dataset. Also, we notice the column for the country area actually contained 2 values, in square kilometers and square miles. This is not typical presentation, as any data cell needs to be a single value per column. Let us also move and examine our dataset using the info function. The results help us to identify further issues. So we notice here that both the country area column and the independence date column are actually assigned the object data type. Obviously, this is not the correct data type to use for these columns. If we try to make a list of all the different issues we need to fix in our dataset, first we need to split the country area value into 2 columns, so we have both values for square kilometers and square miles. Second, we need to remove any non-numerical characters from all the values. Third, we need to change country area column and the independence date column to the correct data type. Then drop and remove any unwanted columns and records, and finally rename the column names to the correct names. So let's move through our list of fixes, and we start with the first item, which is splitting the country area. If you notice that in the column country area, the values for both square kilometers and square miles are stored on the same column, and the square miles are represented within a parenthesis with an empty space between the 2 values. In order to fix this, we typically need them to be in 2 separate columns. So to do this, let's use a Pandas built-in function called split to separate these values into 2 different columns as shown here. So the first part of our code on the left side of the equal sign actually creates 2 new columns on our data frame. The columns obviously here are square kilometers and square miles, as you can see. Then on the right side of the equal sign, we first identify the column country area in kilometers and miles, and we apply the split function, which is one of the many string functions. Anytime we need to handle a data as a string, We need to identify the column name, then we put a dot string and then one of the many possible text functions. So you see, in this case, we applied the split function, which basically will split the text into two different pieces. And one of the important parameters to pass in the string is the string that we will use to split the value. So because we notice there's always one space between the two values, we will use that empty space as our split criteria. The last parameter, the expand equal true, is what you use to split these values and assign them into two new columns at the same time. As a result, you will notice that the column, the country, area, kilometer, and mile was split into two new columns, one for square kilometers and one for square miles. However, we still notice there are some extra strings, such as like parentheses and commas, that need further cleaning. So now we move to the next item in our data cleaning process, which is basically to clean or replace any extra and unwanted strings. We noticed after creating the two new columns in the last section, which are the area, square kilometers, and square miles, that there are still some extra characters within these values, like parentheses and commas. We need to continue our work to clean up and remove these extra characters in order to convert these columns into the correct data type. To do that, we can use the Pandas built-in function called replace, which can be used to replace any specific string character with something else. In our case, we will replace these extra non-numerical values like commas, dashes, parentheses, and so on with basically nothing. Let's just remove them. Let's see how we can do that with the replace function. So we apply the function to both the new columns and run the cell. The warning result here is not actually an error. It's basically just a warning about some future changes in the function that we need to be concerned with in the upcoming updates of a Pandas library. We notice here that the built-in function replace actually can take two parameters. The first parameter here may look a little bit weird, but this is basically just a regular expression. It means all the non-numerical or anything that is not a number. And the second parameter is the new value that will be replaced with. So here we notice it's actually not a space, but just an empty value. So the replace function will basically remove the non-numerical string from that text. We can have a look at how this looks now. And we see the new values actually look a little bit different from what we did before. You see their values here include characters and parentheses, while the new values do not include them, and they look all clean and nice. By now, what we did is we actually converted this column, the country, area, kilometers, and mile, into two new columns. And we further cleaned and replaced all non-numerical values and removed them. So we can now move to the next task, which is basically to change the column data types. Once we finish cleaning our data, like splitting the column into two separate values and removing all the extra characters, we need to finish this work by changing the number values into the correct data types. Currently, the data are represented as text values, and we need to change the country's area numbers into numerical values and the country's independent date values into the date data type. To do that, the Pandas library provides us with the built-in function called asType. It takes the name of the column and the new data type that need to be assigned as the parameter. So let's see an example about how we can apply this function. So you see here, guys, the function takes a dictionary. And within that dictionary, the key values represent the actual column names, and the values represent the new data types that we want to use. We see for the new column about the country's area, we will assign them the data type integer, while the column Independence Day is assigned the data type date. So the code was run without any problem, which means the data type was correctly changed and reassigned. And now we can move to the next part, which is dropping any unwanted rows and columns. Removing duplicate rows and columns is another common task in any data processing project. So far in our example, we notice we have some cases of duplicate data, such as the record of the country of New Zealand, which was listed 2 times, and also we split the column of the country area into 2 new separate columns. The Pandas library provides another built-in function called drop, which can be used to remove any unwanted records and columns. The drop function needs specifying the corresponding axis on which the action will be applied. The axis value 0 will basically apply the action to the row level, while the axis value 1 will apply the action to the column level. So let's have a look at this code example to see how this function works. So we start with typing our data frame name and then type the name of the column we don't need anymore, which is the country area in our case. Then we pass the axis, which will tell us the function that we want to delete the entire column. And then the parameter in place will make that change permanent. By the way, if you ignore the parameter in place, the execution of the drop function will only occur during runtime, which means it will not be permanent. So in place is a parameter that will always make sure the changes are permanent. That's how you drop any unwanted column. If you want to do the same thing, but on the rows, we can do something like this. We notice for the country of New Zealand, there are basically 2 records. So we specify the record number 5 from the index to indicate that we want to remove that record. And to make that change permanent, we assign the in-place parameter to true. We notice we successfully removed that column, and we also removed the extra record of New Zealand. However, there is also another way to remove any unwanted records. So imagine if you actually have more than just one repeated record. So let's say you have 10 different repeated records. Instead of using the drop function multiple times, the Pandas library also provides us with a very nice function called drop duplicates, which can be used to remove all duplicated rows at the same time. So let's do that. And run the cell, and we can see it was run successfully. This function will remove all the duplicate records in one line of code. So you guys see that these 2 functions, drop and drop duplicates, can be very useful for removing unwanted rows and columns. We notice now our country data frame is actually getting cleaner. We did a lot of changes, like we removed unnecessary or unwanted rows and columns, we changed the data type, and we split one column into 2 different columns. We still have one last thing to do. Sometimes data professionals need to change also the column name or the column title in their data frame columns. A common naming format is to have all the title names in small letters separated by an underscore. Luckily, the Pandas library also provide us with a built-in function to do this task, and this function is basically called the rename function. So let's have a look at an example to see how this function can be used to rename our columns. First, we start to type the country data frame. And now we need to specify the old and new column names in a Python dictionary object. So the current column name will be the keys, and the values represent the new column names. Okay, so seems to be running successfully. Let's just go again and see how our data frame looks now using the info built-in function. It's looked like we have successfully changed the column name, and we have the correct data types, and we don't have any unnecessary or unwanted columns. And let us have a final look at our data frame now. And this is how it's currently look like. So guys, in this lesson, we learned about some of the most commonly and widely used data cleaning tasks that any data professional will need to use in their daily work.